Okay, everyone. Thank you very much for joining us today. My name is Michael Newton. I'm the president of Herbert-ABS Software, and this webinar is going to be showing off some of our new features that we've been working on with our HECSTAB software package, focused on the tie-ins that we've done with the Rhino 7 3D modeling software and how we can leverage that software and its add-on Grasshopper to hopefully simplify and speed up the process of putting stability models together and then showing the approach that it takes to do an iterative design, for example. Keith, if you want to go to the next slide. Just a quick little introduction for our company as well. So Herbert-ABS, we focus on marine and stability software. We've got our HECSTAB package, which is focused on regulatory assessment, design, intact damage stability, things like that. We've got HECSALV and Posse software packages. Both of those are focused on the salvage and emergency response aspects of stability software. And then we have our primary CargoMax and LMP onboard loading computers, weight management programs, load management programs, and things like that. So for this one, we're primarily looking at the modeling that goes into all three of these packages. But for most of you, I think most of the group here is going to be on the HECSTAB or HECSALV Posse type of modeling approach. So HECSTAB itself, just a very basic overview for those that haven't seen it. It's a software package for naval architects focused on regulatory stability assessment. It does have some modeling and engineering components built into it. This latest version, version 9 that we've released in the past year or two, is highly customizable, both on the interface, on writing scripts to do stability and analyses directly in the program, as well as putting reporting and documentation as well. And for those of you that have been on the HECSALV or Posse side in the past and have used 8.1, the HECSALV version 9, we are slowly moving those salvage and emergency response features over into this new version as well. So from a ship standpoint, some of the things that we can do in HECSTAB, we can do intact damage stability and stranded stability, longitudinal strength. You can build up loading conditions for things like TNS booklets and loading manuals, things like that, as well as doing detailed stability analyses, both for probabilistic approaches, such as with SOLAS, or through maximum KG or required GM studies based on different requirements for writing arms and damage extents and things like that. And then we also have an offshore package that kind of adds on to the capabilities of the HECSTAB. We've worked with ABS on this directly for them to use in-house as their stability and regulatory assessment approval program. And it's basically applicable for any non-ship shaped vessel. We can do stability on anything that can be defined as a closed volume, basically, looking at both intact and damage stability, normal free to trim calculation, as well as the next generation type of approach using free twist methodologies as well. So that's a very quick overview of our software packages and everything. And at this point, I'm going to turn the presentation over to Keith Gallion, and he's going to go over the HECSTAB data model, and then we'll actually get into the modeling and the tie-ins with the Rhino system. So Keith, I'll turn it over to you.
Okay. Hello, everybody. I see a lot of familiar names on the list. Good to see you here, and hope everything's going well for you. My trip to the coffee shop today, they took off the plastic block in front of the cashier, so things are moving forward here. Hope they are for you too. So just to give a quick overview of what drives a HECSAB analysis, the model we define for that is done in a separate app that we've always called the Ship Project Editor, or we'll call it SPE from now on. And in that software, the basic layout is shown on the right here. So there's a lot of data in the ship project, and a portion of that is the geometry. There's a section here for the geometry, but then there's a lot of other data that defines the different aspects of the ship, draft marks, basic vessel properties, ullage and sounding, geometry, down flooding points, and lots of tabular information, because typically models that we develop, we're replicating existing vessels. So we're actually putting in the data from the trim and stability booklet to match that vessel exactly. So there's a lot of tabular data in this table section to drive intact from table analysis, especially for our CargoMax software. For design and salvage, really the focus of the modeling process is geometry. So this geometry section where we're talking about the hull, the compartment, and some additional little pieces really makes up all you need to do a very detailed analysis. And that's where we're going to be focusing today, and that's where Rhino can really help out a lot. In our geometry modeling, the model we produce has always been focused on doing the computations. And to do the computations, originally all the computations were driven off a wireframe analysis, like in the top right here. So most of the models that we produce over the years are pure wireframe models, and the ship project editor has tools to enter those manually and also to generate them automatically by using boundaries. More recently, I think with the introduction of offshore models, we brought in the ability to model with meshes, like in the lower right here. So you can, in the ship project editor, you can import meshes. And then the ship, in terms of getting data into our data model, it's always been you either model in our system with the station model or you import from some other source. And we have these different avenues we can bring in. And currently the only avenue for bringing in a mesh model is through this raw mesh data, which is a mesh file format. So wireframe meshes do drive the modeling process, but if you're in the design world, especially, it's really desirable to maintain a more precise solid model with real surface modeling capability, so that the surface is fully defined. When you have a station model, you're just doing cross-sectional cuts in certain locations, and if you're that's not sufficient for many other uses if you're in the design mode. And it's also difficult in many cases to model things with stations, especially in the offshore world. So currently shipping with HECSTAB, we still ship the ship project editor that really is unchanged since version 8. But to allow more precise solid modeling, we decided to leverage Rhino. It's a really good tool with a lot of capability for importing and exporting lots of different file formats. So with the plugin, we're hoping for is to be able to let you do your modeling 100% in Rhino and export to analysis, or use Rhino in general for other design purposes, and be pretty smoothly integrated with that. The tool is going to allow us to run directly from Rhino, so we can model in Rhino, run from Rhino, and really never go into the ship project editor unless we need to for reporting purposes or possible refinement. So if it's a purely geometric model, you can largely skip the ship project editor step, except maybe for checking. We're still flagging this effort as a work in progress, WIP. So you'll see that on the plugin panel. So send us your feedback and let us know what sort of tools you need in there to make the process work well. The key part of the plugin, there's a couple of plugins, and the main plugin is the HECSTAB plugin, and that adds a new panel to Rhino. to help you manage the modeling process. You can, this is largely just an organizational tool. And once you start to develop models in Rhino, they can get quite complex especially for larger ships. So the tool helps you organize how you do the modeling, helps you enter the additional data that we need for HECSTAB modeling and go through that process. The types of Rhino objects that we support are closed meshes and other solid geometry. So there's closed poly surfaces. They have a new modeling approach called sub-D. And we're not going to really go into the details of all of those today. But in the end, if you can model it as what Rhino considers it a solid, you can export that out to our software. The core of how we do this is that we are currently enforcing a fixed layering system within Rhino to organize the data. And on the right here is kind of an example of that. So there's we will, when you run our plugin, we're going to be adding this model layer, and then underneath that layer, there's going to be sub layers and sub layers to manage things. And we'll see that when we do the demo. To keep track of the data that we need to drive HECSTAB, we're going to be attaching data to the Rhino objects. So we're going to be attaching data to Rhino layer objects, to Rhino solid objects, Rhino polyline objects for things like sounding tubes. And that kind of all happens kind of transparent to you as you enter data into the plugin. We manage that for you. Coordinate systems become an issue when we talk about going from one piece of software to another. Currently, we're requiring that the geometry be in one of these three fixed coordinate systems here highlighted here. Those could be expanded. That's what we currently do. This is a case where if you have additional systems you'd like to work with, let us know. These are pretty typical. The units system floats with the native Rhino system. In Rhino, under its options, its many options, under units, model units, we're gonna allow you to use whatever units you like for this. And then when we bring data into Rhino and we export it out to HECSTAB, we're going to be managing the scaling that needs to be done to get into the HECSTAB system, which is a metric system that corresponds really to this middle, the origin at midship positive forward system. And of course, our XYZ convention is different from Rhino, so we'll manage that for you as well. So there's, in addition to the main plugin, there's two additional plugins. There's an import and an export plugin that add a HECSTAB ship project file option to the save and open dialogues in Rhino. So from Rhino, you can just open our model files directly, and you can also save them directly. The save will only work if you've modeled using the layering conventions that we impose. Yeah, so in addition to all this, you can use, going back here in the main plugin, you can model using normal Rhino tools. You don't have to go through specifically the plugin to do that. You can use any of the Rhino tools to build solid geometry. We're just adding more typical tools that we need mostly for compartmentation. So you can do that within the main Rhino interface. But Rhino, I think since Rhino 6, it ships with a tool called Grasshopper, which is a graphical, really kind of a graphical programming language, which allows you to lay out operations in order to build geometry. And these pictures on the right here are some examples of how this is done to generate compartments, and this is what we're going to build in a second. And it's quite powerful. It just lets you kind of lay out the building blocks, connect some wires, and you can do things like build compartments. You could do entirely parametric hulls. You can hook the parametric hull with compartment building. There's really not much limit to what you can do. So what we've tried to do with the Grasshopper plugins is add some specific tools to help with modeling, and mostly with compartmentation. So the components we're going to be looking at is these Grasshopper plugin components. We're still trying to make some pretty icons. We're not quite there yet, but they're basically tools to build boundaries that you can use to define compartments, some basic components to help you build the compartments. And there's also a pile of components to do calculations. So in this Grasshopper interface, we haven't really leveraged them heavily yet, but from a designer standpoint, you can do things like compute hydrostatics on the fly and tie those into parametric connections in the Grasshopper model. You can do hydrostatics, tank calcs, and things like that. Before we wrote the plugins, we wrote some scripts that allow you to also export from Rhino, and we're still shipping that with HECSTAB. So Rhino has a Python interface similar to ourselves. So we have our main scripting interface uses the Python language, and Rhino uses two separate scripting languages, and one of them is Python. So we do ship some Rhino scripts that will do the same or similar export process. The difference here is you don't have to use the full plugin experience. You can just model things however you like to model them. And as long as you model in a kind of organized way, you could adjust the script to export your models. So we ship those. You can customize those however you like. Well, if we have time, we'll have a look at that just briefly. We do ship these tools with the current software. To run it, you need the latest Rhino 7 with the very latest updates. Rhino, if you've run Rhino before, you'll be aware that they update almost on a weekly basis, it seems. So you'll want to update to probably near their latest stuff. And there's 3 separate plugin files that you're going to use the plugins install option to bring in. And that brings those 3 we talked about. And it also brings in the Grasshopper plugin. Okay, so let's stop going through a presentation and let's dive into the software. What I want to do today is I'm going to, just to illustrate the UI and how it works, I'm going to import an existing model, and we're going to bring in a tanker model and just look around and just show you the interface. After that, we're going to start fresh and try to create a full barge model, starting just with hull geometry and maybe some simple bulkhead surface geometry. And then from there, we'll export the model, review it in Ship Project Editor, and we'll actually launch launch HECSTAB from Rhino and run an analysis, and then do a design iteration and modify the model and rerun the analysis. Okay.
Thanks, Keith. This is Mike. Just want to, while he's switching over to his presentation, Keith, I wanted to remind you to turn the video off for the recording we're doing for this. And if you could make me host, I can do a couple things.
Sure.
And then for all participants, I will point out that Zoom does have the capability for a chat and a question and answer area. So if anything comes up that you'd like to answer, we've got a couple of us here in the back that can answer questions and anything that pops up. Otherwise, when Keith's done with his demonstration, hopefully we'll have a few minutes at the end that we can take any other questions that might come up if you have anything that you'd like to discuss.
I'm looking for the option to make you host.
It would be under participants and then find me on the panelist and then more.
I'll gotta find. Oh, panelist.
If you can't find it, don't worry about it. It was just, okay, thanks. All right, back to you then.
Okay, you are now host. Okay, so let's, let me get this out of my way. Let's load up Rhino 7. Okay, you're in. So let me load up the tanker model that we mentioned. You can see I've already got this HECSTAB plugin loaded. And under tools, options, plugins, I had already done the install process. There is a help document installed with the software that runs through the install process. So I've got that there. There is a HECSTAB command. There's a number of commands installed with the software, and one of them, the main command, is HECSTAB. And this just lets you show and hide the HECSTAB panel. So, you know, for most of your Rhino work, if you're in there a lot, you're not going to want this panel in here. So you can, this allows you to show and hide it. The listing of commands shipped with the software, going back to options, plugins. Is listed here. The main command, and these are largely listed in the help document. It's still, that's the help document is also a work in process, but HECSTAB command is here, and you'll see quite a few additional ones that we're adding for different purposes. Most of these commands, you can type them on the command line, or you can run them using buttons on our plugin, which is how we normally do it. That's how I'm going to run it. So let me load in the tanker model. So since I've got the plugin loaded, I can just simply go to File, Open, and then let me find under my documents. So in terms of sample data, when you install HECSTAB, you get this full set of sample data. There's analysis packages, some commands you can load in, writing arm criterias, sample models, which I'm going to load one of those, scripting, custom reporting, and then under Rhino 3D, you'll find the Barge tutorial that we're going to go through today, so that you can rerun it there. But right now, I'm going to grab the tanker model for this VLCC demo model. On the way in, as I mentioned, we model in our software with largely wireframes, and this particular model is a fully wireframe model. Depending on what you're importing for, you may want to bring those wireframes in, which is this section here, or you may just want us to convert those into a triangular mesh for rendering purposes. We in our analysis, we have the wireframe model, but we're always also meshing the wireframe model with a triangular mesh. For most of the time, that's purely for visual purposes, but we can also drive the computations. So I'm just going to bring in the triangular mesh because it looks prettier. Experimentalists ignore that. coordinate system is the important thing to think about at this point. I'm going to just stick with this origin and AP system that you can flip to whatever you like. In Rhino, this z-axis, we're always going to be up. So a plan view will be in the XY system. That is different from our own internal system, but this lines up with more CAD conventions. The origin is always going to be at centerline baseline. And typically, that's going to be to the molded geometry. That's going to go okay. Okay, so what the software has done, it has loaded, is grabbed the ship project file, and then it's converted that geometric data into Rhino objects, attached some data that we need to track, and put it into an appropriate layer. And you can see the layering system has now been filled out. So under the hull, we've got the main hull layer, which is where the geometry is going, but we also have some additional hull-related items. We have some draft marks in there. In this case, we have some wind and display profiles. It's visible. So the hull, also under view, render one of these viewports. Okay, so we've got the hull model. We've got some draft mark information, which is these blue lines here. The wind display profile is this bit here. So it's brought everything it can into the software geometrically for the hull. Under compartmentation, it first organized by compartment group. And then, for example, if I show the, here, the full compartmentation is in there. And since we specified a mesh model, that's what we got. So Rhino's able to render this nicely. And you can navigate these models completely using the Rhino tools. It's just Rhino objects and layers. If I, for example, want to get rid of an entire cargo group, if I delete the layers, that's also deleted the data from the HECSTAB model. So you can manipulate things directly. If you'll notice, also we got things like down floating points, these points up top. It brought in the down floating points that were attached in this model to a couple of the compartments. If you using the plugin, you can navigate it here and use the HECSTAB command to load this panel if you don't see it. We've got the basic particulars under settings. As I navigate the tabs, what it's doing is it's trying to do things you would have to do in Rhino to just see what you want to see. It's manipulating layer visibility. So for draft marks, it's just showing the hull plus the draft marks. So these are the draft marks that brought in from the VLCC model. And these are represented just by any curve type in Rhino. And we're adding tools in here to do things like generate some curves that are attached to the hull and things like that. Those sort of tools are expanding, and there's tools for most of these things I'm going to show you. If you've already modeled something in Rhino, but it's in the wrong layer, you can also use this tool to attach the data. And then all that's going to do is it's going to grab the data and put it in the right layer and tag it with additional information. The hull model is the hull geometric model it brought in. And And really the meat of that is this one in the HECSTAB model. This is what we would call a space and attached to the hull. Okay. And then the compartment section is just a navigator really to help you move around all these layers that we had generated for you below. And in the table, we also list kind of the key data that we're attaching to this to model compartments. So for example, we've got compartment permeability. We've got the space type is flagged as cargo oil. This is all data that was brought in from the ship project, attached to, in this case, the layer in Rhino. And then you can just type in new values here and modify the model. Up top, we provide some filtering options to make it a little nicer to move around Rhino and look at the data. So for example, if I only want to look at, say, the compartment group that I care about, that I'm currently selected, I can select this tool. Then I'm only seeing the cargo group. I'm only seeing the fuel. So these are my fuel tanks, diesel tanks, all my lube tanks. Maybe I want to overlay the hull on top of that. That kind of got a little bit. And you can do things and then reset that back out, see everything. If you're trying to search, if you've got a large model, you're trying to search for it, I'll find the engine room. There it is. And I think I'm going to set it to show only the selected compartment. And then there we go. So it's just this interface here is a way to navigate the model compartments, enter the kind of the key compartment information really quickly. So a couple of tools here for things like adding new compartments, mirroring compartments, removing compartments, changing the groups of compartments. And again, a lot of these things are things you can do directly with Rhino. You can rename a layer, and that will rename your compartments. You can move a compartment from one group to another, and that modifies your model. And we're also adding tools here to kind of do the more typical stuff quickly. Reset that filter. So as I've modeled, let me get this first off. And the compartment details is where you dive into if you want to edit the details or just look at the details for a particular compartment. It gives you information on computations, capacities. That's where you can also edit permeabilities and things like that. You notice here that we also support down flooding point definitions. These came in from the model. One addition to HECSTAB on the analysis side is that you can define down flooding points on the fly during analysis. So if you're in a sort of a design stage where you don't really know where they are, and maybe where you're trying to figure out where they go, you don't need to put them in the model, and you would probably do that on the analysis side, at least initially. For existing vessels, if you're for emergency response or thing, you probably just go ahead and put them in here. Sounding devices, I don't think this vessel has any, but you can define the shapes of sounding tubes, sounding ullage tubes. And once you define the shape in the ship project editor is where we have all our tools for generating table information, but we're starting to add also tools within this software for generating things like tank tables and ullage and sounding tables. So the tools are starting to come into play in the software as well. We'll run these tools when we do the barge. Okay. So I've imported, looked around, and that's really basically the modeling process for each of these. Let me go back to spaces. Each item in this list here under spaces corresponds to a solid in Rhino. So this piece right here in Rhino, let me go to properties, is a closed mesh, if you see here. So a closed mesh is one of the ways you can represent solids in Rhino under the mesh menu here. But you can also do them with these sub-D objects. You can do it with poly surfaces, so connected surfaces. So any of these tools to develop solids and all the Boolean operations and high-level capability for building things is all there. And our goal with all of this HECSTAB interface is to try to leverage all that, but also pull out the parts to make the modeling easier. Okay, so let's shift gears. This, and I'm going to start a new model. I'm going to open up not a ship project file, but a regular old Rhino file. And I've got a starting barge model. Let's see what I've got in here. Okay. So this is a starting barge model in terms of my layers. Let me turn off these guys first. You see I've got all my layers off except this default layer. And in this layer, I've got just if I select that and look at Rhino properties, this is a closed solid polysurface. So it's basically a bunch of NURB surfaces stitched together to form a solid. So it doesn't have any, no holes in it. Okay. In the case of a barge, it's pretty simple. It's more challenging, certainly, to model a solid of a ship's hull. That's a whole nother discussion in Rhino, and not one I'm an expert in, so I wouldn't give that talk. But so I think the biggest challenges in the end of using Rhino will be at some layer you've got to develop the base hull model, because from the base hull model will flow all the compartmentation. And the higher quality your hull model is, the higher quality the entire model is. So it's worth spending the time on it. In this case, this is a NURBS model, so my compartmentation is going to produce NURB geometry. I can start with mesh geometry using the plugin, and then the generation process will end up giving you mesh geometry for everything. So you can do all these same operations I'm showing you using either meshes or surface-based models or sub-D models. Okay, so you can do either. Okay. So let's start the modeling process. I'm just going to call this barge demo. Give it a length. Beam is 18. Depth is 6. And keel thickness. We are currently in the Rhino unit system, which down in the lower left, you can see down here is the metric system. 0125 is the current system. So it's a 12.5 millimeter keel thickness. Okay. Now, in terms of where this model is currently, we want it to be centered about the coordinate system we've defined. So if we've entered an LVP beam and depth, and we have a particular coordinate system, that kind of establishes where the hull should be. How do you check to see if that's right? But there's a tool here to show the ship system. Just for to see with both of them highlighted. So let me unhighlight that one. Shows it. So this is how the particular bounding box is lining up, and things are looking good. We could do some additional checks using Rhino's built-in and that analyze tool. So there's tools for analyzing length and point positions. So you'll want to go through that process pretty well. If I want, many of the tools in HECSTAB will give you these previews. You'll give an opportunity. You can extract this box if you want to use it for helping reference things. I'm going to leave it off for now. One thing you'll notice in HECSTAB, the behavior of many of these tools will behave like Rhino normal tools where you'll be prompted for information on the command line. Some things are graphical, but most of the prompting you'll get is on the command line. So as soon as you hit a button here, you'll have to look up command. So to build the hull, let's focus on that. If I want to build the hull, I need to bring this geometry into our system. So I'm going to hit this plus sign here. It's going to ask me to pick some geometry to move to the layering system, hit enter. I can either copy that. If you want to keep a copy of it in your original location, you can. I'm just going to move it. That moved the geometry into this hull layer here, and then the plugin detected that and brought it in, and I can update the calcs. The plating thickness at the bottom is also 0.012. Okay. I'm going to start saving my Rhino file. Working. Okay. At that point, we've got enough to actually drive an analysis. We've got a hull model, we've got some particulars, and we can go File, Save As, and then the other plugin we talked about was an export plugin. So this HECSTAB ship project file, I'm going to replace the one I've been working with. And you'll be prompted for some information you get to control. The key thing to control is whether you want to export the solids out as mesh model or station model. We can run the calcs from either one. For ship shapes and like this, either approach works pretty well. The mesh system is the most reliable because we're using the same calculation mesh that Rhino uses. So you're going to get exactly the same computations in Rhino as you do in HECSTAB, which is a nice thing to see. We're refining the station and offset approach to try to get better matches more often, but in general, mesh is really the preferred approach for perfect matching. And it's going to do some additional information for generating tanks and other information. We don't have any compartments. That's not really going to do anything. Let's save the file. I'm going to have a quick look at it. That's it. And this is our ship project editor. And all that did is it generated the hull model. Theoretically, there it goes. And you can see it's a mesh-based model, and it brought in the plate thicknesses and things, so that we can actually drive an analysis from this. But what we want in the end is a full model if we're doing a damage study. So then we can start to add compartmentation. To do that, we've got to start adding the layering system in here. So let's put in the backbone of the layering system. These layers get created for you in some situations, but if you're manually putting stuff in place, you'll want to generate them. There's two tools up here to do that. This left one creates the basic layering system here for the hull compartments and the boundary surfaces that we're going to do. And then the second tool is for the compartment, kind of adds the typical compartment layers. I'm going to pull those in, and the typical compartment layer colors. Okay. So these are the different groups. So I can use this interface to start modeling compartments. So for example, I can add a new compartment layer here. I can generate a compartment here. So if I want to generate a compartment, I'm going to say pull up my picture real fast. So this was the barge that we showed. Let's just generate this, a real easy one, just to show 22.8, 13.6. I'm going to generate cargo oil. tank, it's CO3C. And then the process for generation is really the same as we do in Ship Project Editor, except now we're working with higher level surface object. We're going to pick a base solid. We're going to then enter up to six possible bounds. And the bounds can be entered either by just typing a planar location or selecting a surface. I'll just do it the simple way right now. I'm going to do 22.8 for the aft bound, 33.6 for the forward bound. Y is port starboard. This is negative 4.5. And then the Z is up and down. I'm going to skip those, just hit enter. And I've got a compartment. So this added the compartment here. You can see the layer was automatically added here. We got it here. We can type in our permeabilities. We can edit that the space type is a cargo oil space. And really, at that point, that model is done. It's not very flexible in that we didn't use surfaces in the model to create it. We could have created surfaces for the aft forward bound, port starboard bound, and used those instead. And that would be a better way to do it. But I wanted to just show you the quick process. So that's kind of the manual way. You can keep doing that, and we're trying to add more tools in here to drive that process to make that easier. When I export this out, I'll get this one compartment. So you could do a one compartment damage test from this. But more interesting is we're now integrating with Grasshopper. So we installed the plugin. We also installed some plugins to this tool. Let me load that up. So this is a graphical, essentially programming interface. And if the install works correctly, you should get a HECSTAB menu option or a tool option on the right. And they call these components. And we've added, what we're going to look at today is components to build surfaces and components to build compartments is really where we're going to be focusing. So for example, if I want to start building this, I want to create some planar bulkheads at a couple frame locations. So my primary frame locations are at frame 20. So in Grasshopper, these components look like this. If you right click on them, you can usually rename them. I'm going to call this frame 20. Okay. Once you've got that, very easy to duplicate it. And I'm going to call the next one frame 38. Oops. I'm just going to do a couple because we're running a little short on time. And frame 56. But these are a couple of the kind of key frame locations. I can set the location of the bound. You can see, let me see if I can make this there. Organize this so we can all see. Let me just do one view there. Okay. So you can see as I click around in Grasshopper, what it's doing is it's actually creating graphical components. They only live in Grasshopper until you tell Grasshopper to what they call bake it. So this frame 20, if I right click, set a number, I can put the location of frame 20, which is at 12 meters from the AP. And now this location corresponds to frame 20. And I can do the same for this. And frame 38 is at 22.8. And let's just do that to accelerate things. We'll just do those two. And you can see it's starting to do some things in the model. I'm going to go back to here and I want to turn on the hallway. See things. Turn on. Go to wireframe view just so things don't. Okay, that's a better way to see it. So you can see for these two here, I've created these two locations. If I want to go further and create this boundary here, I could either predefine these sort of things in Rhino. In our plugin, we're trying to add components to let you generate these kind of simple boundaries pretty quickly and manage things like making sure the boundary extends up to or beyond your base surface. So the ruled bulkhead here, so this we can call, we'll just call this the wing. Let's do the starboard side, I guess. And this is set up, this particular component is set up so you can just define some real basic information. So let me leave that there for just a second. Have to cheat. Forgot the name of the component. It's a panel. So I need to add a, what I want to do is add a, what they call a panel. The way this is set up is what I want to do is try to define that bulkhead, which is some real simple things. And this is just the longitudinal location of a location and the transverse position. Looks like I'm doing those. That is the starboard side, yeah. And so this is longitudinal location, transverse, longitudinal transverse. If I connect that in here, I pasted in the data, but it's supposed to be a multi-line data. So anyway, I defined this data, I've passed it into my bulkhead. And if you look in here, you can now see that this little bit of data is now generating this entire bulkhead with just a minor bit of data. So now if I want to use this information to generate a space, I can add a compartment. And so if I want to generate something called CO, let's do 4C. Okay. It needs to start with some solid geometry. So in the Grasshopper world, there's a component called geometry. I can use that to grab the hull. So I can grab the hull here I can feed that into here. Okay. I can set the aft side of this one to this space. Turn off forward side to here. I'll show that one. That's good. And you can see that I've already cut this boundary here aft forward using the hull. And if I want to use this as we said we were going to do the, well, let's not do the center, so then I have to do, let's do the 4 starboard. So this wing should be the Y, see if I get this right. I got it right. So I've connected the wing as the starboard bound, as the port side boundary essentially, aft forward. Okay. So that process generated this compartment. In the Grasshopper world, this data is not part of the model yet. It's not even, it only lives in Grasshopper, and there's a process called baking. And the standard bake, there's a standard bake option, and we've added some custom bake options. So if I want to bake it, I just click bake, pick the group I want it to go in, and now my model has this space. So the process in Grasshopper kind of goes like that for all the compartmentation. But what you'll find is that things get very repetitive, and there's a lot of copy paste of similar things. So let me open up, since we're running short on time, I'm going to open the worked solution, which I already loaded here. I'll switch to that. So here's what it looks like when you kind of complete the building process. And this is what we've shipped with the software. Okay. So that one I just built is this cargo 4 starboard. And the only thing in addition that's going on here, it's building this aft, it's the aft deck boundary, and this is similar to the boundaries that we had developed. But it's done everything. The coloring here is controlling the compartment groups. So in Grasshopper, there's a grouping process, and these groups you can set colors. So the colors you define here and how you group them controls how we do the baking process. Okay, and the process to build the full model is I can do individual bakes, but that gets old. Once you've completed your model, the individual bakes gets kind of old. So we added some tools to sorry, get this organized a little bit. I'm going to get rid of these that we created. We added a tool, it's this tool here, which is a master baker. And that's this component here. If I right click, you can bake and rebake all compartments. So that went through the process of my Grasshopper model, and it baked everything. So everything defined here, it's now created the full compartmentation directly from the definition you see here. Okay. If I go back and look at, close this a little bit. These colors come from the Grasshopper grouping. The only thing that Grasshopper currently doesn't do is define things like the space type, and the permeability right now is just a default 0.98. So you'd still have to hand edit this information. If you regenerate the Grasshopper, it should maintain your edits as long as the compartment name doesn't change and the grouping doesn't change. So now I've got a fully baked model. I can save that, and I should be able to just run it. I should be able to review it. I can run it. I can file, save as, and look at it in Ship Project Editor. If I want to see if it'll launch up, what it's doing is it's taking the Rhino geometry, building a ship model, saving that to a particular temporary location, and then it's launching HECSTAB. To do the analysis. Now we're out of time, so I'm not going to actually run an analysis, but so here's the model. And all of the compartmentation that we just built comes in, and all these groupings, colors, done. Okay. So if I add a child, do a very quick intact analysis. Seven distance density. Rules run. Going back to Rhino, so there we've got our first intact analysis based on this vessel, and we could then start to do our damage stability studies, etc. Just to, I know we're running over, but I'll do one thing real quick. What I wanted to cover a little bit was, now that we've got this model defined in Grasshopper, it's quite easy to manipulate. So if I can find Grasshopper again. And depending on how you lay out the Grasshopper, if you're building the Grasshopper with the intention of designing, you're not quite exactly sure, maybe the hull isn't set yet, or maybe bulkheads aren't quite where you wanted them to be. I can, for example, move bulkheads around quite easily by if I just change the input value on this one bulkhead to whatever I want. So if I flip that to some other number, it's right now at 21.8. And you can even do things like in Rhino, in Grasshopper, there's a very useful tool called a number slider. You can attach that to that boundary. Let me get out here so we can actually see what that does. And when you set the range of it, let me just go from 0 to 60, which is the full length of the vessel. So this sets the bounds of the slider. So at that point, I can, you see, I can slide this boundary wherever I want to. Once I do this in Grasshopper, what that's doing, if I select the things that depend on it, you can see this compartment here is completely dependent on this slider now. So you can control these linkages in lots of different ways. So if you have some intention that you don't know exactly what the model's going to be, you can set up your linkage and have a fully parametric model. And I can do things like go back into the original hull model. I can shrink it and stretch it, and then regenerate this and shift boundaries around however you need to. It's up to you how much you want to link these things up, but it's quite powerful. It gives you lots of capability. I'm not going to do any more in terms of analysis, but I did want to point out that you can drive some computation. So for example, this wire goes back to the hull. This is the hull model. So this is a case where we've taken the hull model, we've built a kind of a mini ship model out of it. We've computed some drafts, and using one of our components to compute a plane from draft measurements, that's done a hydrostatic count. So, and this is the basic hydro result. I can manipulate drafts and get different hydro results. So you could use these in a design mode. You could use these capabilities for playing around with hull geometry to target hydrostatic properties. And then you can do similar things down below here. We're actually doing some righting arm calculations based on entering some light ship weights and centers, righting arms, and down here some sample tank calculations. So when you load the samples up, have a look at those and let us know what you'd like to do with them. And again, this is a work in process. And please, yeah, let us know exactly what you'd like to see up here, because we want to make the modeling both easy from this panel and more powerful to do from the Grasshopper. So we want to put the components in that just make this process easier. Okay. All right, I think that since we're over, I think we should probably wrap that up and then take any questions that you have.
Okay. Excellent, Keith. Thank you very much. We've answered a couple questions so far. Dale's been putting some ones in here. The one that wasn't answered, I guess, was getting permeabilities from in-cell into a permeability table in Rhino or Grasshopper. I'm not sure if we have that capability now, but it's something we could probably look into, right?
A permeability table?
Yeah.
I'm not sure I follow that.
I think he wants to be able to adjust permeabilities on the fly. So does that compartment generation block, does that have a permeability input to it now?
Oh,
or no?
in the Grasshopper itself?
Yeah.
I think it does, yes.
Okay, so yeah, so it sounds like the answer to Dale's question is probably yes.
I think the question he's asking is probably actually a bit simpler. Can we just copy and paste into that table?
He's talking about SPE capabilities.
Oh, you mean copy paste into this table here?
Oh, yeah.
We'll make sure you can. You can do currently you can do things like edit. You can edit a bunch of them. If I wanted to change it, you can change a range of them. Honestly, I don't think I've even tried the pasting yet.
Okay.
So I think we should just put it on the list for testing.
Okay.
And you can manipulate this stuff under tools, Grasshopper. You'll see some entries. They're currently not being used. There's, like when I built these spaces, are entries for things like permeability, type of compartment, and optional thing for just turning mirroring on and off. So you can do this from Grasshopper as well. It's just in this case we didn't bother. Were there any others?
I think that was everything for the most part. We can review some of the other ones as we wrap up from this.
Okay. Well, thank you, everybody.
Yes, thank you very much, everyone, for attending. Go ahead, Keith.
And I won't ever forget to turn on the multi-line option next time.
That's okay.
But there's if you've never used Grasshopper, I think I was a bit doubtful when I first started looking at the Rhino plugin. I wasn't even thinking about Grasshopper. But the more I used it, the more the wires can get a bit much visually for bigger models. So I think if you're doing bigger models, I would tend to break these up into smaller Grasshopper files, just because of the wires. But if you look at the quantity of in terms of the capability, there are lots of things you can do in Grasshopper that are quite interesting. So it'd be interesting to see what you come up with. So let us know how you're using it. That's all.
Okay, well, thank you, Keith. Thank you, everyone, for joining us. We'll send an email out with a link for the video if you wanted to review anything. Look for the next releases of HECSTAB and HECSALV as they come out. And look for our next webinars. We're going to be aiming on doing these on a monthly basis and kind of focusing on the new features and things that we're excited about working on and showing off to our clients and potential clients. So keep an eye out for all that, and we will hopefully see you in the future. Thank you very much, everyone.